Before continuing with decision structures, we have to take a moment and discuss truth tables, what they are and how they work. They're really pretty simple. A truth table is just a way to evaluate multiple conditions. Okay? In our case, we're only worried about 2 conditions, but truth tables can accommodate as many conditions as you would like. So how a truth table works is like this. On the left-hand side of the truth table, these lines represent left and right. On the left-hand side of the truth table, we have 2 conditions. Our conditions are meat and vegetables. We'll discuss that later. On the right-hand side is D for dessert. Okay, so we've got meat, vegetables, D for dessert. And then we've got and, or, and not. Well, again, we'll talk about these later. So, meat, vegetables, dessert, and, or, not. Then, on the left side of the truth table, this represents, below this line, represents every possible outcome you can have with these 2 conditions. 0 is false, not. 1 is true, yes. Okay? So, I know, okay, a little confusing right now. Let's break it into regular English so you can understand. I have a daughter named Katie. Katie is not the best eater in the world, so I've got to make some rules for her and her dinner. And it's pretty simple. It says, Katie, if you eat your meat and your vegetables, then you get a dessert. Meat and vegetables, dessert. So far so good? Should make sense. So let's look at the possible outcomes we've got here. Meat, 0 means false, she didn't do it. So false, didn't eat her meat, didn't eat her vegetables, does she get a dessert? Nope, that's false. Okay, so that's just a 0 right there. You're not adding the numbers up, you're just calculating are they true or are they false. So again, in English, meat and vegetables, then dessert. Well, meat is no meat, so no meat, but she did eat her vegetables. Does she get a dessert? Well, no, because I said you need to eat your meat and your vegetables to get a dessert. So this is a no. So we'll put a 0 right there. Next one, meat and vegetables dessert. Well, she did eat her meat, but she did not eat her vegetables. Sorry, Katie. Again, that's a 0. No dessert. Aha! Meat and vegetables, then dessert. She did eat her meat, she did eat her vegetables, so yes, she gets a dessert. So the truth table for an and truth table with 2 conditions, the only way you can get a true, or it happens, the only way you can get a true is if both conditions are true. So true and true is true. True and anything else or falses are all false. Okay? Makes sense to you, hopefully. Meat and vegetables, the only way she can get her dessert is if she eats her meat and vegetables. So let's look at an or truth table. Let's change it just a little bit. And we're going to say, Katie, if you eat your meat or your vegetables, well, then you get a dessert. By the way, this is Katie's favorite. So, she does not eat her meat, she does not eat her vegetables. Well, of course, in the or truth table, she does not get a dessert. However, meat or vegetables, she does eat her vegetables. Yes, she gets a dessert. Meat or vegetables, there's her meat, but she didn't eat her dessert. Well, she still gets one because meat or vegetables. And meat or vegetables, she eats both of them, so she gets a dessert. So, how does this evaluate? In or truth tables, false and false is false. As long as you have a true, your or is going to be true. By the way, I'm going to step aside just 1 second and say this has nothing to do with a project or anything else, but I do want to explain in case you hear the word exclusive or. An exclusive or just means that you cannot have 2 ors. It just has to be one or the other, but not true. If this were an exclusive or, not just a regular or, but an exclusive or, true or would be false on an exclusive or. Okay, I'm going to come back to where we're at, and that's going to be and or. So the and says either both conditions are true or none of it's true. An or statement says as long as one of the conditions are true, it is a true statement. Okay, so that is an and an or truth table. The last one we want to look at is the not operator. And a not, by the way, is symbolized by an exclamation point, or called a bang. Okay, not or bang. What a not does is it just takes the result of the truth table, okay, and it negates them. It makes it untrue. So for example, if you not an or truth table, a not would look false, I shouldn't say one, true, false, false, false. It just negates your outcome. Okay, it changes it. You say, why would you use that? Well, there's a lot of times where you just want to look for one one answer, one solution, maybe a yes or a Y. You want to ignore everything else, and so you'd want to negate. Okay, and again, we'll look at that in an actual classroom example later, but that's what a not does. So a not is really simple. It just turns trues into falses, falses into trues. So this is a truth table, and or.